Hello and welcome back to another video from Posito Mouse, and today we're going to be doing circle theorems. Let's start off with the first one, number 1. So for any line that reaches to either side of the circle that comes below the diameter is known as a chord. Now, the perpendicular bisector of a chord will always pass through the centre of a circle. So if that's a perpendicular bisector, the middle of the circle would be here. It always passes through and meets it at 90 degrees. Okay, so number 2. If we have a triangle here which base touches the diameter and we label our angles A, B and C, B will always equal 90 degrees no matter where we put it on the triangle. It will always be equal to 90 degrees. Number 3. I have a tangent line, which is a line that touches the radius just on the edge. This is a tangent line. If this touches the edge of a circle, then we know that if we draw a line here from the tangent to the radius, to the centre of the circle, that this angle here would be equal to 90 degrees. Number 4. The subtended angle is the angle here, which is directly opposite to the interior angle. Think about it when you look at something. If you see something at 22 degrees, for instance a tree, the angle that you can see directly gets expanded. So this angle here is a subtended angle to this interior angle here. Okay, number 5. So angles that are in the same segment, so a bit that is the other side of a chord and are connected to the same arc here, are equal. So we could tell using that knowledge that the angles here and here are equal to each other. Okay, so number 7. So if you have an arrowhead shaped space shape that connects to the edges of the circumference on its edges, then this angle here, let's call it x, will always be double this angle here, let's call it b. So we know that because it's here, x will be equal to 2b. Okay, so number 7. This is a silly quadrilateral. What I mean by that is it's a shape with 4 sides that is all of which corners are touching the circumference. Now what's different about this shape is we know that opposite angles in this shape, let's call this one A, and all add up to 180. So that would be the same for all 4 corners. So we know that A and B equal 180 and C and D also equal 180. So number 8. 2 tangents that meet each other at a point are the same distance apart. So for example, if the point here is A, and this is B here, and this is C here, we know that from A to B and from A to C is exactly the same distance. The angle between a triangle and a tangent is exactly the same as the angle in the opposite segment. This is also known as alternate segment theorem. So these 2 angles would be exactly the same. Okay, number 10. So 2 triangles that share the same base here have the same angles at the top if they're touching the circumference. So these 2 angles would be exactly the same. Okay, let's try this example. Now it may look a bit complicated, but it's nothing we haven't already seen before. Because we know that these 2 tangents touch the circumference at equal distances, we know that A and A here are equal. And we know because this is 60, and interior angles in a triangle have to add up to 180, we know that 180 minus 60 is equal to 2a. And we know that 180 minus 60 is 120, so we can calculate that a is equal to 60. From then on, we know that when a line comes and meets the radius at 90 degrees after touching a tangent, that whole line here must be 90 degrees. So here and here. And because we know that A is 60, we know that this angle here must be 30 degrees. So let's call it B. So we know that B is 30 degrees. So that does that at 2 points, so we also know that this B here is 30 degrees. And because interior angles in a triangle have to add up to 180, we know that 30 plus 30 is 60, so that this angle here must be 120. Okay, and we know now that this angle here is half of whatever this angle here is. And we know that half of 120 is 60, so we know that D must equal 60. And that's all you have to do. Alright, that's all I have for today. Thank you very much for watching. Remember to like and subscribe and share this video for anyone else wanting to learn how to do circle theorems. Thank you.